Guys, if you don't know what to do, just please follow this kind of guideline, the template. This is, as I said, you can do pretty much everything in year 11 physics using this rule too. Always start from the things. Figure out the net acceleration given. This time is given as 4 meters per second down. Remember this, okay? Means that you're given net acceleration, which is at 4 meters per second squared down. So in a way, we can write that as minus 4.0 meters per second squared. If you like to, that's fine, okay? As we consider the negative direction for the downwards. This means what? We have AX is equal to AY, that must be equal to AZ. In terms of the acceleration, minus 4.0 meters per second squared, downward too. Now, we only consider downwards, we can just write the downward because you may have mix up the horizontal and the vertical later on. But for now, just leave that for now. So that means net force on X can be found by mx times AX, and you to get 2 times minus 4 giving you minus 8, or 8 newtons down. Make sure you can clearly indicate the direction of the forces. Force on the Y, my times AY, that's 3 times minus 4, giving you minus 12, or 12 Newton down. I just write it down here for the direction conventions. And lastly, F on the Z would be mz times AZ. That's a 4 times minus 4, giving you 16 newtons down. Once you get up to this stage, and just time to just figure out individual block, okay? So Matthew, for the Z, what are the forces applied on the Z?
The mg force.
Yep, so mz and g and?
Tension T1.
T1, let's make it T1, that's good. Okay, T1, okay.
And then overall Newton 60 down.
Mx, Z, yeah, 16 newtons down, okay. 16 newtons down, very good. So this is the force that applied on that box Z with the net force of the 16 newtons given. Means that we can find the net force in Z again by adding up the T1 plus that M and Z G here like this. Okay, this is given as what? Minus 16. Make sense up to here? Then T1, it would be simply 16 MZJ, but this should be, should be plus of the minus MZG due to the direction as well too. Moving that to the other side, you get a minus 16 plus M, mass to the 4 kilo, 4 times 9.8 like that. Then you'd get 16, 4 times 9.8, and minus 16, they're giving you 23.2 newtons, okay? Now, tension force work in the both directions, so you can write that both direction on X and Y. Does it make sense? Okay. Am I using something different? No, this is exactly the same method that I've been using, teaching you today. There's a new, it's not a new method, by the way. It's using the net force values all the times. All right, let's go for the Y. David, tell me about the forces on Y.
MYG.
We have MYG. Tell me more about the directions as well.
Down.
It's moving downwards, so we have MYG is moving downwards, and then?
The T1 tension force down.
The force for the T1 is moving it down, good, and?
And upwards second T2.
T2, very good. Then we have a T2 moving down here. Now, do we know what the T1 is? We found it from the previous here. Do we know what the MYG? We do. What about the net force?
12 newtons down.
Okay, we have a 12 newtons down here like this. Okay, just be careful with all the direction, because having the positive and negative direction mean they make a big difference in your values later on too. So, the net force on the Y is given as minus 12, as we found that. Okay, sum of all the forces that we have, so T2 plus minus T1 plus minus MYG here like this. Then we can find the T2 from that, moving all of that. So minus 12 plus the T1 that we found, 23.2, plus then move that aside. MY, what's the MY? They minus 3 times 9.8 like this. Then 23.2 plus 3 times 9.8. Okay, and minus 12, you're going to get 40.6 newtons up in this case. Oh, sorry, that's both direction. That's it. That's how we can find T2 and T1 straight away. Okay, now, like, it looks like really complicated if you're just thinking about action and reaction force, how to find that, but if we just separate it and separate it into the small systems, it should be a doable question from now on. That, oh, you got to think about the net forces only, what forces are applied on each other, and the net acceleration of course too. Okay, all right, let's bring this one then. Page 61, finally, the pulley question. All right, on the example there, okay, I give you about 30 seconds. Can you draw all that relevant forces applied on both 12 and 4 kilo there? Can you show all that relevant forces? Oh, assume that there is no friction, by the way. There's no friction in this case. Okay. All right. What would be the forces acting on 12 kilo then? Normal reaction force. We have one. Good. And the wave force is so I write m the 12g. Let's write it there. Okay, to differentiate. Okay. Anything else? There's a tension force. 2. Left or right? To the right. Okay, it will be tension force to the right. Okay, and what about in the 4 kilo? The wave force, which is pushing it down. Okay, so m4g. Let's write it down. And the tension force. Can we say these two tension forces are equal amount, equal tension force, but in the opposite direction? Okay, same as I'm hanging something up that we have the opposite direction tension force applied with the same amount. Okay, we may consider that there will be a friction force, depends on the questions too. So this is the general force diagram for pulley questions that you need to consider about all the forces direction here. In this case, we consider that as a smooth surface, means that we don't have any frictional force applied here, so we can ignore the force for this time. But if you're given the frictional force ever, then you need to include it in your force diagram too. Okay, now, Andy, if we hang, okay, let's imagine this in here. We had a 12 kilo, okay? Now, I hang the 4 kilo in the pulley there. Then, if the 12 kilo is stationary before we hang that, after we hang the 4 kilo, what would be the direction? Where would be the direction of the 12 kilos movement? Straight away? I'm telling you, there's no frictional force. There's no friction. It's nothing holding it back.
So it goes to the right?
It goes to the right. It means we have a force that's pushing the 12 kilo to the right. What about 4 kilo then?
It's going up. Actually, no, it's going down.
It's going down because as soon as we hang that, you know, because it's a slippery, by the way. Slippery means that you will kind of push this 12 kilo at the same time, push the 4 kilo down. Okay, now what is this? This is a combination of your horizontal and the vertical forces that we learned now. This is a combination of both. Yeah, it's getting a little complicated, but nothing so complicated here yet. Okay, what I'm going to do is I'm going to do the exact same thing that we applied in here. Okay, first of all, we know the direction of the acceleration or net acceleration is moving downwards here. So shall we find, first of all, the acceleration of the system? How do you find the acceleration system? Then we know that the 12 kilo and the 4 kilo is moving in the same direction. So the only force that's making this to move is the net force of the from that the weight force of the 4 kilo. Because of that, it started moving down, started moving to the right. Does it make sense? Okay. So the applied force in this case over here means, can we say the net force is therefore the let's bring this one out. Considering the other situation there, the net force is on 4 kilo and 8 kilo. So let's draw that. It's a slightly different approach. The net force from the 12 kilo is going into this direction on 12 kilo. Okay, we have a tension force applied, and that's it. So can we say in this case the tension force is same as the net force applied in here? Okay. Same for this 4 kilo arm there, the tension force is applied, and there's the mg pushing it down. This has the net force is moving it downwards there. Does it make sense? Okay. Then we're going to consider it here. The net force on the 12 kilo. How do you find the net force on 12 kilo? This is found by m12 times the acceleration, net acceleration in the system. What about this one? Net force on this is also found by m of the 4 kilo times that the acceleration system as well too. In other words, we are able to create the acceleration system. The tension force is then equals to 12 times the A. Okay, from this diagram here, we can also get the tension force is equals to the net force. As this is equals to T plus minus mg. Okay, but considering the direction of the net force, it would be negative. So I must write that as, minus m4 times a of the system. Yep, as I'm considering the direction, the negative direction there, so minus 4a system is equals to T minus mg like this. Everyone okay? Andy, you okay? Your face is not looking good.
Yeah.
You good? Got it? Okay. I pause for 10 seconds. Have a think about here. I put the negative value of the negative on the net force because it's moving downwards. I'm just following that what we promised all together. The weight force is moving downwards to put the negative value to. T is the only one that's moving up in this system. Make sense? Then we have a 2 T's exactly the same with the same A. So what we do is equation 1, equation 2. I can substitute equation 1 into 2. Then you to get the 12a is going into here. So minus 4a is equals to 12a minus mg there. Does it make sense? Okay, then add it up to mg. Oh, sorry, mg as in like m4g. I should say 4 times g. It's better. This is better, okay? That means it gives you that, move that 12a plus 4a is equals to, 12a plus 4a equals to the 4 times g, 9.8. Therefore, acceleration is 4 times 9.8 divided by 12 plus 4. Okay? So this is what? If you think about it in here, isn't that? Have a look. The one on the top is known as the net force applied. The one on the bottom is net mass that we have to. So what is this? It's exactly the same method as the first one. You get it? Okay? Doesn't matter whether it's connected to pulley or not. I get the same acceleration value. And you show they're working out over here. This is the method. That's what? 4 times 9.8 divided by 16, apply the force, then you to get 2.45 meters per second. This case, I would not consider the direction to be downwards all the time because we have a 2 separate acceleration. One is moving to the right, one is moving to the down. So it depends on the masses. The net acceleration is 2.45, but for the 12 kilo is moving to the right, for the 4 kilo is moving downwards. Does it make sense? Okay. Important to think about how we get this. The net force on each object, so this means what? This is same as acceleration that applied onto 12 kilo, same as acceleration that applied onto the 4 kilo too, because they're in the same system. Exactly same. This is what we did in the individual acceleration. Then how to find the force on individual forces? Force on the 12 kilo is found by 12 times that acceleration, 2.45. So 12 times 2.45, you get 29.4 newtons. Consider the direction to the right. How do we find the 4 kg? Same method. We have the that's kilo of the 4 times 2.45 again. 4 times 2.45, you get 9.8 newtons to the down in this case. Then let's find the tension force. You can either use any of those here. As soon as we get the acceleration, you can use that equation 1 to find the tension force. Okay, so tension force is then, question C, it's T is equal to 12 times acceleration, which is 12 times 2.45. So 12 times that, you get 29.4 newtons in both directions. Okay, it looks like it's slightly different to the previous questions, but I'm using the same method. Okay, I found the net acceleration. Yep, didn't I? I found the net acceleration, and I can use that into the force diagram too to find the individual tension forces. Okay, so let's do the next question related to something really similar to. Okay, for each of systems, find that acceleration of the systems and the net force on each object too, the tension of each, and neglect the frictional force. Okay, so let's follow that method. First, let's find the net acceleration of the system. Can be found by, think about it here. If there's a frictionless, if there's a kind of slippery place, as soon as you place the connect the 8 kilo, you know that it will push it down, it will move this to the left. Okay, it's not hard to imagine because you just say, oh, it's slippery. It means as soon as you put the 8 kilo down, it's kind of pulling this down. Does it make sense? Okay. Then we will consider that the acceleration is from the force applied divided by the net mass that you have, which is what? The force applied in this case is from the weight of the 8 kilo. 8 kilo is the one that exerting the force. So 8 times 9.8 divided by 8 plus 16. Same method as we did in the previous questions too. So 8 times 9.8 divided by 24, you get 3.27 meters per second squared. I will leave the direction here because it will be different directions for in the perspective of the 8 and 16 kilo. But does it make sense? I got it here. Shall we do the next? The net force on the 16 kilo is m times 16 times the acceleration, because the same acceleration value. That is what? 16 times the 3.27, which is giving you 52.32 Newton. Let's consider direction to the left. The net force applied on the 8 kilo would be 8 times the acceleration, 3.27, again 2. That's a 26.16 Newton. Now, in this time, downward. Still, I'm following the same method. Yep. Then 3. Consider the forces that applied. So I've done the net force on each object A and B. It's clear. Now to the C, tension in each string in the rope. Have a think about the 16 kilo first of all. 16 kg. This is connected to the tension force only. We are ignoring the weight force of that because it doesn't really give any frictional force. But in a case you have to consider about the frictional force. Remember that we may need to consider about the normal reaction force of it. But not for now, okay? Not for now. You'll get the questions in your topic text next week though, okay? So please remember what I said. That tension force applied, that means what? This case, the net force is equals to, net force 16 kilo, the net force is moving into this direction as well too, is equals to the tension force. That's it. So we got the tension force, which is what? 52.32 newtons to the left on both directions. Or we can do the same method for the box, the 8 kg. Have considered about this, it has the weight force, the mg pulling it down, we have a tension force pulling this up, but the net force in this system is what? Going downwards in 26.16 Newton down. Okay, so what I do is, net force is a negative 26.16. That is equals to adding the T plus minus mg. So T is equals to minus 26.16 plus m, the mass is 8 times 9.8. So 8 times 9.8 minus 26.16, surely get 52.24, the same value, 32. Or you get a different value, 16 times 3.27, 32. 8 times 3.27. Okay, minus that, 8 times 9.8. Yeah, 52.24. So similar value, same value, tension force 2. So when you use the first system or second system, that you should get the same tension force applied on both of them. Okay, that's due to a sigma error, due to that 3.27. It's not exact to 3.27. 8 times 9.8 divided by 24. Yep, 2666. So that times 8 and minus 8 times 9.8. Yeah, you get the same value. Does it make sense to all? Okay, so please remember this. Remember this. If you're not too sure how to solve the question, please follow the step-by-step guidelines too. The key point is, first, you need to figure out the, you need to understand about net forces, net acceleration on each of the objects too. Okay, you will get some sort of the question like this. I give you a clue. You will get a question. I'll pick the one of the the most interesting question is, you have uphill, you have pulley, and this is kind of hang like this. Wow, wow. A bit of like an application of that pulley questions too. But have a think about what we did about the pulley, that it has a forces applied, you know, there's a tension force applied there too, there's a forces applied in here, and this is can be divided into some degrees of that, okay? So this is a combination of the everything you learned today. So you had it in your homework for your exercise, okay? So please, this time, please challenge it, push it, try it, and you don't have to get it right the first time, but please learn from your mistakes. You will make lots of mistakes in the forced questions. Yes, I'm expecting that you're like, you're gonna not get 100%, but push it, challenge it, and if you can just overcome these questions in module 2, that's it. The rest of the questions in the module 2, we're gonna deal with the energies and momentums. They are relatively easier than this forced question. I pick this is the hardest, the most difficult in year 11, and as well as year 12. Okay, this will come revisit you again in the forces, because we're gonna learn about different type of forces in year 12, gravitational force, centripetal forces too. But if you don't understand that force diagram, or how you don't know how to apply that, there's no chance you can do well in year 12. I really mean it. Okay, so this is time. This is a good time, perfect time to challenge and practice these force questions again, again, again. Any questions? No? Okay, then I bring your homework today. Does anyone try for physics Olympiad this year? Okay, you don't have to. I just want to say, most of the Olympiad questions are using these forces again.